Hi, and welcome to the Jungle Gym Workshop. Today I'm going to be working on a valve that came off of a DE vertical grid Hayward filter for a swimming pool. These connections on the ends of the valves were threaded into the black valve, which is a multi-port valve, with Teflon tape. And they've been in service for about 7 years now, I guess. And the connections started to leak. When I looked, there was some cracks along the top edge of the black valve coming from the threaded PVC connectors. I had called a pool store, and they sent a guy out, and the people that put it in, and they packed it with some RTV or something, and it leaked again after 3 days. I called them because their work was warranted. They came back out, and they this time took this looks like epoxy putty of some kind and slathered it around the connections. That held for about a month or month and a half, and then started to leak again. Of course, I was out of the 30-day warranty on their service, and just a little tired of having them to keep coming back and not really fixing the problem. So I was going to replace the valve. So I had cut it off, cut the pipes, because it's all glued and everything, and I'm going to put it back in with quick release valve, connections, so I can remove this valve. It has them on the filter side, but not on the PVC side, the two lines. So I'm going to add them to those lines, and but before I ordered the valve, I decided I was going to look at this thing and try to figure out what is going on. I'm going to try sealing it up and stop the leaks. There are a bunch of micro cracks in this plastic. I'm going to find some way of sealing them. Okay, so the first step will be to grind off all the old epoxy or whatever that is they put on there. Remove the threaded PVC connections, which should spin out because I think they were put in with Teflon tape. And then clean up everything, replace the threaded PVC connections with new ones. Only this time I think I'm going to glue them in and permanently seal them. I won't tighten them very tight because I have, through looking online for solutions and problems, found that these valves are very prone to cracking. When those PVC threaded or ends are threaded in, they're supposed to be threaded in by hand until they snug, and then like another half a turn, 3/4 of a turn, something like that, which is not very tight at all. And they depend on a good bit of Teflon tape to prevent the leaking. So what I'll do is I'll goop up the surfaces real well. Put in the PVC parts. I'll just thread them in until they snug up a little bit, and that's it. And that should make it a pretty strong seal. All right, after I threaded the inserts back in, I've tried to film it, but I accidentally deleted the clip when I was transferring the files. But what I did was I just did the plumbing. I added the pipes into the end of the PVC unions there, the threaded unions, and put the quick couplings on there. And everything was cleaned up and ready to go. I was going to use epoxy on this, but that's pretty much what they had used, except that theirs was more of a putty. I was doing a little research and trying to find out how PVC is glued and fastened and what works with it. And I'm somewhat familiar with the solvents and things that they use for it. And I tried to identify the materials that were used in the valve, and I know the PVC pipe is PVC, but the valve body itself, they said that anything in black was ABS, anything in white is PVC, although I think the black color may have something to do with what Hayward decided to make it. I'm not exactly sure that implies definitely that it's ABS, but the plastic does appear softer. It does appear to just not quite be like the PVC. Now it could be, but it just didn't strike me as being PVC. In the meantime, what I had done was I went over to Harbor Freight, and they sell a welding kit, a plastic welding kit, which is basically a soldering iron with a little, the tip is a flattened plate. And in that kit, they gave you pieces of PVC and some screening it's steel screening, kind of looks like the window screen, except it's a steel mesh. And what I did was I cut small pieces of that steel mesh, and everywhere there was a crack in the PVC that I could see, I laid the screen on top of it, set the iron on it, waited until the screen melted into the surface, and then I just wiggled the iron a little bit to as the plastic came up through the screen to smooth it out. I didn't push it very hard. I did not put it very deep. It's basically just inside the surface. And then I did that to the entire patch, and I went around both of the inlets for the valve. One's an inlet, one's an out. And everywhere I saw a crack, and there was about 6 of them, I put a little piece of screening. I noticed some other very faint, mild surface cracks. I don't know if they go through. I did not bother putting the material on top of that. What I decided to use instead of epoxy on the surface was a slurry, a little thicker than the PVC glue. The PVC glue is basically acetone, MEK, and some other materials, resins or something. The solvent that cleans the pipe is basically the acetone or something that basically dissolves the surface a little bit. So what I did was I decided to take pure acetone, and I decided I was going to use ABS because I think that's what the valve is. I'm not really sure, but it's a little easier to work with than PVC. I got a roll of printer filament. It's 1.75 millimeter ABS 3D printer filament. I picked up a roll of it off of Amazon. I think it was $18. I took a little jar I got out of the trash, filled the jar about halfway with acetone, took about 20 feet of the filament and a pair of cutters. Later in the video, I had to mix some more up, and I'll show you how I did that. And I just cut the filament into it, probably put 10 foot of it in first, and then put the lid on it and let it sit. It almost immediately started to color the acetone, the color of the filament. Now I used a gray filament. I could have used black, but I decided I was going to use a gray because it would show up in the video. As to if it was black, it may not show up as to what was painted over with this slurry and what wasn't. So I used gray, so there's really no mistaking it. And I kept going, and if you look up ABS slurry, they're basically in the 3D world and probably in the plastics world, there's there's 3 stages to it: juice, glue, and slurry. The juice they use to put on the piece of glass on the printer so that the print sticks to the glass. And it's a very light mixture of ABS in the acetone. The next is a glue, where it's a medium amount of ABS in there, and it looks like glue almost, like super glue consistency. And then there's a slurry, which acetone is used as a fingernail polish remover, or was used years ago as a fingernail polish remover. And fingernail polish was like a slurry. It's really thick, goes on thick, and that's about the consistency you want the slurry to be. If you make it too thick, it becomes very hard to spread because it dries almost instantly. You make it too thin, it's just runny, and you're going to have to put on 100 coats. If you make the slurry about like the consistency of fingernail polish, it goes on thick, and 4 or 5 coats will give you a nice heavy coating of it. And I began to coat the pipes with that. Alright, what I did was I made an ABS slurry. It's made with acetone and ABS printer filament. And as you can see, it goes on thick. And I'm painting these surfaces, and we'll see how it holds up. Okay, here's 3 coats of the slurry. It's pretty thick, and you can see when it dries, it turns into plastic. I've coated it moderate coats, moderate to heavy. And I'm going to probably try to cover it until all the black is gone, so it's a thick, clean coat of the ABS slurry. Okay, I've gone through about 2/3 or a third of a jar of the slurry. I'm going to make another half a jar of slurry. Basically, you fill the jar to whatever amounts. This is just some kind of a brown sugar and spice ham glaze jar I happen to get out of the trash. You just fill it to whatever level you need. You take filament. In this case, I'm using 1.75 millimeter ABS 3D printer filament. I think it's about 20 bucks a roll. We can buy the cheapest stuff you can get a hold of if you're not printing with it, because you're just going to dissolve it. So in there's acetone, and I just cut up chunks of this ABS. I think when I made about a third of a jar, maybe a half a jar total, I used about, I don't know, 20, maybe 30 feet of filament. So I'm adding a little bit more to it to finish the job, and see if I can get this so you can see what I'm just cutting it with a pair of cutters into small pieces. You really, I mean, you could throw blocks of it in there. It just takes longer to dissolve. You don't have to really do anything. You put the acetone in there, cut this filament up into the jar, put the lid on the jar and let it sit. If you're making like I think they call it ABS juice for the printers to help stick the ABS material to the base, you just put a few pieces in and you just keep going until it gets to a cloudy color. It will be the color of the filament because the acetone, of course, is clear. So when it dissolves the filament, it's going to be exactly the same color as the filament. So if you're going to make, like I said, a juice for the printer bed to help hold the prints to the base, just put a few in there. If you're going to make ABS glue, which you can use to glue 3D printed pieces together, it's even more of it than you use for the juice. And if you're going to make the slurry, you put a lot of it in there. You don't want it to get too thick because it tends to dry too fast as you're putting it on, and I don't think it adheres as well or fuses as well. The difference between this stuff and the glue is glue, like if you're trying to plug it with epoxy, those leaks, that bonds to the surface. So the materials are still two separate materials and they're bonded together. This stuff, when you put it on, the acetone dissolves the top layer of the material you're putting it on, which I believe is ABS. I can't really tell. It's black. It could be PVC. It seems to be a little softer than most PVC stuff, so it could be ABS. But this dissolves both ABS and PVC, so it doesn't matter. But this stuff, when you put a layer down, it softens and fuses the bottom. It softens the material on the bottom and this material, of course, which is inside there. The two start swapping molecules or whatever. They basically fuse together. And when the acetone evaporates out of it, you end up with one piece because it goes from PVC to the joint to PVC, and that joint is PVC. So it basically is like welding it together instead of gluing it. So this stuff works a lot better than trying to epoxy those valves. I've tried epoxy. I've tried silicone glue. I've tried the pool putty. Well, I had a guy come out originally when it leaked from the pool store. He came out and glommed on this white pool epoxy putty, and you can see it from the beginning of this video. It made a mess of it, and it leaked. It held up for maybe 3 days, 4 days, and then started leaking again. And by the time I called him, his 30-day warranty had. Before I knew it was really leaking again, his warranty had expired. So this stuff really does the job. What I did was I laid some. When I was working on the surface, I first sanded the surface. I got off all the epoxies, all the glue, all that pool putty, everything came. I got it off of it. I cleaned out the threads. I glued up the PVC threaded joint, ran it in there like they said. I just went hand tight. I didn't go hand tight plus anything because I glued it. I put a lot of glue on both the inside and outside. I ran it in, hand tightened it, and that was it. I took acetone, put it in this jar. I took these brushes, which I bought. I bought a bag of them for, I don't know what they were, $10 off of Amazon. I dipped in acetone and I wet the surface down really good. And as I was doing it, as I worked it a little bit, I could see the black starting to come off of the onto the brush, which is, of course, is the ABS or the PVC or whatever the valve is made of. It was coming off onto the brush, so I knew I was starting to soften and treat the surface. I did that to clean the surface real good and to prepare it for the slurry. I then took the slurry, and which I made up, to get it to the right thickness. It took I wasn't in any rush, so it took me about 2 days. I filled the jar halfway, cut in a whole bunch of it to where there was a nice pile on the bottom. I let it sit overnight. I kept shaking it like this every so often, and when it came out more like the ABS glue, it was kind of runny. I took some more of that filament, another 5-10 feet of it, cut it up and put it in there. And I think the last time I did it, I put about 5 feet or 4 feet of that filament in there, and it got pretty thick. If it's too much and you don't have as much filament, you can always leave the lid of the jar open and let a little of the acetone evaporate out. That will thicken it up also. But again, if you make it too putty-like, for me it was too hard to put on, number one. Number two, I'm not really sure how well it bonded with the valve, the plastic below it. So I would keep it not runny, but acetone is fingernail polish remover. Most of the ladies out there will know that what the consistency will be like, because this reminds me of the consistency of fingernail polish, which is kind of thick, and it goes on kind of thick, and so I got it to that consistency, maybe a little bit thicker, and I put 4 coats of this onto the valve, and that's pretty much all I did. I filled in the cracks. As the video showed, I filled in, the seam between the PVC and the and the valve, which I'm assuming is ABS. I filled that seam in so that it was flush. You can't even see the seam anymore. So that bonded both sides to the PVC. So here's the valve, covered in 5 coats of the ABS slurry. I'm going to assemble it onto the pool pump now and see how it works. Okay, it's been running about 2 weeks now. No leaks from the valve assembly up top. It's completely dry, so that stuff did bond and appears to be working pretty good. In fact, once this stopped leaking, I did notice a slow drip coming out of the bottom of the pump motor where the seal inside had started to go bad. So I have replaced the seals, and I also, while I was doing that, replaced the bearings inside the pump, and it's running quiet and dry. So this looks like it did the trick. Probably can be applied to almost anything on the pool. The filters or whatever that develop small cracks can probably be patched with this stuff. It forms a molecular bond with the surface. It fuses itself right in there. So it's not like epoxy, which would sit on the surface and bond to it. This stuff would dig into the plastic and become part of the plastic. So it looks pretty promising. We'll see what the longevity is. But like I said, it's been a few weeks and it's running dry and not leaking at all. See you later.